Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and the topic is thermodynamics in chemistry, and in this topic this is lecture number 18. In this lecture I will explain you irreversible of expansion of gas in vacuum, and numericals if time permits. Okay, so first of all we'll take irreversible expansion of gas. So here we will take one cylinder. This is the initial state, piston over here, and a gas is filled in it. Initial state pressure is P1, volume is V1. There is no intermediate state and we will get direct final state. This is final state where pressure is P2, which is higher, and volume is V2, which is also high. Pressure will be low, but volume will be high. So the condition is P1 is greater than P2, but V2 is greater than V1. Okay. Now this can be explained with graph also. Pressure versus volume graph. Here we have P1, which is higher, P2 is lower, V1 is lower volume, and V2 is higher volume. So P1, V1 is initial state. This is initial state. That is P1, V1, and final state will be P2, V2 over here. This is final state, P2, V2. So the system directly go from P1, V1 to P2, V2 like this. But in this case, volume slowly changes and therefore the work done will be this much only. This is work done. That is called W irreversible. Okay. So this is what work done during irreversible expansion. Now see, we'll write something. If the expansion is performed irreversibly, means single step only, from initial step to sudden change, and we'll get final state. Irreversibly by sudden reducing the external pressure to the final state pressure P2, the irreversible work is given by following relation, that is work irreversible is equal to minus P2 into V2 minus V1. In both the processes, the state of the system has changed from A to B, but the work done is much less in the irreversible process. So in the irreversible expansion process, work is always very less. Now we will see expansion of gas in vacuum. Expansion of gas in vacuum. Sorry. This is initial state where pressure is P1 V1, and here the most important part is P external. As it is in vacuum, P external will be 0. That means there is no pressure. So if a gas is expanding into vacuum, that is P external will be 0, no pressure is applied, then piston automatically move upward without any effort. Okay, so here we can say that W is equal to V1 to V2 P external dV is equal to 0. The reason is P external is equal to 0. That means work done will be 0. So in vacuum there is no work done during the process. Okay. Now we will see some numericals based on all these formulas. So let us take first numerical. The first one, calculate work done when 1 mole of an ideal gas at 25 degrees Celsius and 5 atmospheric pressure is allowed to expand irreversibly against the constant outside pressure of 1 atmosphere until the internal pressure has been lowered to 1 atmosphere. So this type of numerical is given. Now in this numerical, the most important part is the gas is allowed to expand irreversibly. Okay, an ideal gas expand irreversibly. So now according to this, we have to see which type of data is given to us. Okay, so here you are given V1. V1 is equal to nRT upon P1, and second is V2, that we can find out with nRT upon P2, because P1 and P2 are given. So here V1 would be number of moles are given 1, n equal to 1, R will be 0.082, okay. Temperature in Kelvin 25 plus 273 matlab 298 Kelvin upon pressure P1, which is 5 atmospheric. So this way you can find out V1. Then we can go ahead with V2. V2 would be nRT upon P2, where n equal to 1. This is 0.082, 298 temperature, and P2 is 1. Okay. So this way you can find out V1 and V2, and then W irreversible is equal to minus pressure into V2 minus V1. Okay. So here pressure will be 1, V2 we can find out, V1 you can find out, and then get the work. This work will be in liter atmosphere. Okay. If if you are given the conversion of liter atmosphere to joule or calorie, then definitely you can find out in work in joule or calorie. Otherwise you keep it in liter atmosphere. Okay, so this way you can find out irreversible work. Next numerical. Second one, 1 mole of an ideal gas at 25 degrees Celsius is allowed to expand reversibly at constant temperature from volume 10 liter to 20 liter. Okay, calculate work. So here the most important part is you are given the gas is allowed to expand reversibly. So according to this we have to use W is equal to minus 2.303 nRT log V2 upon V1, because you are given two volumes. So that you can put the values of number of moles, R, T, V2 and V1, and you can find out work in liter atmosphere. Thank you so much.